Definitions in kinematics. Words have very specific meanings in physics, and we're going to look at some of the words related to motion now. Displacement is the distance travelled in a stated direction. It is a vector quantity and so has magnitude and direction, whereas distance is a scalar quantity, having magnitude only. Let's look at an example. We want to travel from A to B. The blue squares are in the way, so we'd have to travel something like this. This could be a distance of maybe 11 meters. Our displacement would follow this arrow, and we have a displacement of 7 meters southeast. Instantaneous speed is the speed at a particular instant in time. It can be found from the gradient of a distance time graph. A speed camera measures your instantaneous speed using radar. It then takes two photographs half a second apart. This is to give proof of your average speed over this short time interval. In general, your instantaneous speed and your average speed over such a short time interval will be pretty much the same. Average speed is the total distance travelled divided by the total time taken. For example, if it takes you 3 hours to travel 120 miles, your average speed will be 40 miles per hour. That's 120 miles divided by 3 hours. Over the journey, however, your instantaneous speed would have varied between 0 miles per hour and 70 miles per hour, or even more. Motorway roadwork sections are often covered by cameras calculating your average speed. They record your registration number at 2 places a known distance apart. If you cover the distance in too short a time, you are speeding. So average speed is calculated as distance divided by time. Velocity is speed in a stated direction. It is a vector quantity, and so velocity has magnitude and direction, whereas speed is a scalar quantity, having magnitude only. If we look at the journey seen previously, the distance travelled was 11 meters, the displacement 7 meters southeast. So we could say that if the journey took 10 seconds, the average speed, being the distance travelled divided by the time taken, would be 1.1 meter per second. However, the average velocity would be the displacement travelled divided by the time taken, and this is 0.7 meters per second southeast. Acceleration is the rate of change of velocity. It is a vector quantity, and so we must state its direction. This means that slowing down is classed as negative acceleration, as we have a negative change in velocity. So acceleration is calculated as the change in velocity divided by the time taken. Here we have an object which travels in this circle, which I'll mark out like this. Now at this point the object had a velocity in this direction, whereas at this point the object had a velocity in this direction. Therefore the direction of its velocity has changed, and so its velocity has changed. So an object travelling in a circle at a constant speed has a constantly changing velocity. As acceleration is equal to change in velocity divided by time taken, the object is actually accelerating, even though it is travelling at a constant speed. We don't have to cover circular motion any further in this part of the course.